hoe doe je Zeilinger? If you have open Spider, Control N, Control S, and then save it for today and to code those by the way. New script. How to create functions yourself. And already creating new functions yourself, I think we are already Excel beleid. Because Excel is a function out of it. If you want a specific function for your own model in Python, you can create it yourself. After that, we spoke how to help yourself, some help functions, and some operation, some storage options, like a string, but also a list, and how to access that and how to change it with built-in methods. That was all last week. Now, today is module 2, which will be on conditions, loops, and errors. Based on the previous times I gave module 2, module 1, regime. Maar we might just miss Azure Ansat service. So if you expect to take service, already prepare yourself to maybe take the Seretania service, like I think Azure Ansat. But maybe we'll just finish in time. We'll see. Module 2. What is part of this module? Well, you cannot see it. This module will speak about firstly conditions, if, else, and else if. Up to the coffee break, somewhat. Then from the coffee break on in the morning, or a bit later, just before lunch, we'll already make a start on loops and we'll work the rest of the days on on loops. And only the final Asramist Deka, I will also still speak about the most common errors. This one is very important because if something red appears on your screen, error, that does often not mean that it's figure out. Not often you can, if you know when I errors happen, if you then carefully read the text, most often you can already solve the problem yourself. So that's why in this module I point out the most common errors for you. That's at the very end of this module. Most of the time we will be spending on loops, but we'll start with conditions. So as I already said earlier, but for each module, what you can do is create a new script file, Control N, new file, Control S, and save it as m2 code.python. In there you can save all coding. Good. So let's start right away with conditions. Conditions in Python. The idea of a condition in Python is that you execute some code, be honest, some condition is fulfilled. Did I remember that correctly? In Amarinha, if is be honest. Look it up. Okay, good. One time back I mixed be honest and Calhoun up. Calhoun is or, right? Or else. That I'm going to use a lot today, because today we're going to use conditions a lot. The idea of a condition is that a certain code, your script has certain code, it runs into a condition, and then if the condition is true, some other code is executed. But if the condition is false, this code is skipped entirely. So in that way we can build in filters in our data. If the data is between 0 and 100, do this. If it's not, well, skip it or do something else. So the programming conditions betaan als verleiding. And we'll just start with the basics of conditions, having one condition and only one action, having one condition and multiple actions, and how to combine multiple conditions into one. We'll start with those three basic things. And I hope you remember the relational operators. Is it equal to something? Double equal sign. Is it not equal to? Exclamation mark equal sign. Bigger than, smaller than, bigger equal, smaller equal. Those are of course very important for conditions. Because these operators, we saw by the give us the booleans true or false. And the true and false can guide us through the condition loop. Be honest, true, do this. Be honest, false, do that. So conditions and these operators, relational operators, will be used. Good. Let's start right away with one condition, one action. Do the following. And I wrote that, do it in the console, but actually in the script editor would be a bit more convenient. Right, test me is 6. It doesn't really matter where you do it for this one. But the code below that you have to do in the script editor, if test me equals 6, print test me is 6. Just like with functions by Postman, with the if statement, also this indent is very important. This tab explains to Python this line is part of this if. So again, same as with functions, if something needs to be part of this if, put a tab before it. So if you wrote this and type this, then select it and run all the code and tell me what happens. So you can select it, you can run it. What happens? Yeah, and run the code. then it works. Yeah. What does it do? What happens? Oh, yeah. So only exactly what is underlined. So this. Yeah. Oh. Okay, well, you started the rest. I will also show my computer what it does. I show the rest, it all works, and it's printed test me is 6. Now do the following. Set test me to 5, and then tell me what happens. So change this test me to 5. And then what happens? Nothing? Why? Because 5 is not 6. And if you look to it, if you read it aloud as English language, in this case it perfectly works. Test me is 5. Okay. If test me is 6, please print test me is 6. Only be honest. This will happen. Yeah. So this gives false. If I run all of this, nothing happens. Why? Because this part is false. Yeah? Only if this is true, all the code belonging to the if statement is happy. So all code in an if block will be executed if the condition equals true. So if Python reads if true, then it will be printed. If, according to Python, there is if false, then nothing will happen. So Python is just replacing, it knows test me, oh, that is 5. Test me equals 6. 5 equals 6. False. And then it starts reading if false. Okay, I have to do nothing. I can skip whatever is happening. Now, quick silly question. What can we change here? Leonard options are. What can we change in the condition? In this condition? To let this be printed. So, I want this to be printed. What can I change here? When will this be true?
If it's equal or
equal or
less.
So that is less or equal. Yeah, let's see. Yeah, now it works. Or of course we could have is not equal to 6. Or we can simply have smaller than. So you have Leonard tools and you have to pick the right tool at the right moment. Now of course this is stupid code because it's prints test me is 6. If it prints that, well then it should also only print be honest sadistic. Yeah? But anyway. Yeah. So that is one condition, one action. And the condition is tested and the negative is happening, one thing. Now let's move on to one condition, multiple statements. Do the following. To the if block, add the line print finished. Yeah? So add the following. Print finished. Just change everything back to 6 and tell me what happens if you run it. Oh, precies bij de hand. But, you open this one. And we break the spider. So what happens if you add this?
It's display finished.
Yeah, it prints both. If this is right. In other words, any code that you want to be part of this condition, you can just type. You can type as many code that you want under here. As long as it's part of this one, it will happen be honest true or not be honest false. Quick question. Watch my code. What will happen if I run this off?
Finish just printed.
It will print only finished.
Yeah.
That's exactly the case, of course. So again, the indent is very important. This tab tells to Python, this is part of this if statement. I see tab yellow, so it's just Layla code. So Python moves through this code, it reads test me is 5, if test me equals 6, no, okay, skip, move on to the rest. Okay, print finished. Yeah, it prints finished. So mind your indent. If you want this to be part of the condition, it needs to have a tab. Good. So all code in a block under the if statement will be run if the condition is fulfilled. You can include as many actions as you want. So we have one condition, one action, or one condition, multiple actions. Let's now move to multiple conditions and multiple actions. I hope you remember logical operators. And or. Yeah? Because with the and or, we could combine individual conditions into a bigger one. In the if statement, and the true based on the false is needed. But if you have multiple conditions, you can combine them with and or to have true and true resulting in true, or true or false resulting in true resulting in true. So with and or, you can combine multiple conditions and turn them into one. So in the script editor, write the following: if value bigger than 0 and value smaller than 10, print you chose this value. Yeah, I also do it here. If value bigger than 0 and smaller than 10, print just a string. And you can set, for example, value to 3. Like that. Yeah. This one is this new code. Yeah. And if you've typed it, run the code and try it with different values. For example, 3, but also Asra Ants, and tell me what happens. Is with not with platforms. Yeah. Okay. Yeah, and what if you change value to 11? If you change it to Asra Ants,
Yeah.
of course nothing happens. Yeah. So let that syntax. Yes. Everything is doing. Everything is doing. Yeah. Good. Yeah. So, couple of small important points. The if statement, as with also later on we'll see with the loop, but also with the function bouwdocument, it should always start with something and then end with a colon. This colon is very important. That's just what. Anything belonging to the if statement should have a tab. Now also, if you just continue here, you are sticking in the tab. So some of you start now typing if value is This means that this code becomes part of this one. If you want that, okay. We'll see that later. But if you don't want that, well, remove the top. And just to bring you back into memory, if for these two lines you want to remove the tab, you can do Shift tab. If you actually want to give it tab, you can do tab. All lines you select work along with that. Okay. Now for the rest, it just works perfectly as we expect it would work, because Python just starts replacing everything. Value is 3. It reads a condition: 3 bigger than 0, true. N smaller than 10, true. True and true results in true, so this will be printed. If, however, this one is at hand, then of course nothing will be printed, because then we have if bigger than 0, true, and smaller than 10, false. True and false results in false. Python reads if false, nothing happens. So in this way you can combine as many conditions as you want. The most important rule in this is all individual conditions need to be between brackets. Yeah? That's to keep track. If you forgot the brackets, there is another very nice tool that is because of Spider. I forgot the brackets here, I can just select Udum and click on the first bracket and it will be both. Now, anything you select and you give a bracket will give both. That actually also is the same as string. If this I want to turn into string, I think I can just do that. Yeah. Anything you select and you want something around it, Spider will automatically put it at both sides. Good. With AND, of course, both conditions must be true to result in true. We already saw this buitenvorstelling with OR. Bij Jans, and the condition must be true. Quick question. With this code, can you think of a value that will result in not printing? A min value where will this not be printed? So I made a small change. I changed this into what? Is there a value Yes. Which value?
11.
11. And then it will not print.
Because you choose 11.
Yeah, exactly. Then it will print. And now it also prints with 3. Is there any value that it will not print? No. There is no value that is not bigger than 0 or smaller than 10. Every value is bigger than 0 or smaller than 10. And so this code will always print. In other words, this is stupid code. If the code always prints, why do you use the condition? Yeah. So this shows you can, now the logic is still easy, but the more conditions you start combining, the more you have to puzzle about the logics. Do I need OR and AND here? And if I want to filter this specific region out, how to filter it? And that requires practice. This is stupid code, this is always running. It should of course be AND to make it a bit more relevant. Good, so far we saw a condition and then some code running. Or not. Yeah? It either ran or not. Now, the problem of this code is, it's not a very big problem. The current code, if it's between 0 and 10, it will print something. If it's outside the range of 0 and 10, it will print nothing, it will do nothing. it would be nicer if we would have a Bihones do this, Kadhone do that. And that is also available in Python. If it is true, do this, else Kadhone do that. In that way, we always make sure something happens. So then in this case, we can print you chose 3 or 5 or value out of range. That's of course much better because it gives the warning to the user, or it gives a message. If simply nothing happens, you are not sure, did the computer not run? Is it because of the condition? So with the if statement, Python conducts an action if some condition is fulfilled. With the else statement, Kadhone, we can include actions if that condition is not fulfilled. So in the script editor, add the following: else print out of range. Yeah, and if you change it to 11, then it should out of range. So that we about the syntax, yeah, the else should be back to it. This one, choose. Yeah, because you said value 3. You chose single thing. Change it. And this results in false, so it will do this. So now we have code that always does something. If you enter a number. If I choose 11, then the first one is false, so it will fall back on the else. So it will print out of range. So this is much better code. It will always do something. Now, very important again, mind your indents or tabs. Anything belonging to this if statement should have a tab. The else is not belonging to this if statement, but it's not je if lunch, it's je if hunt, basically goed. Eat. So it should be on the same level, of course. If you put this one tab further, it becomes part of the if. Now it should correspond with this. So this should be on the same level, and don't forget the colon. Anything belonging to this else, of course, should have again a tab. Yeah, so that helps Python keep track of your files. So the if and else statements, all code in an if block will be executed if the condition equals true. If the condition equals false, all code in a corresponding else block will be executed. Corresponding is here the most important word. You cannot have else yellow if. If you only run the else part, you will get an error. There can only be an else corresponding to an if. That's also in English or in American. You cannot not simply say Kadhone do that. Kadhone do what? You need to start with be That's just exactly the same in Python. You only have an else combine two lengths. You cannot have nouns on and set. It needs to be corresponding, maar they need to be on the same type. Okay, so be honest, so now do the following. Write a piece of code that prints this is int if the variable value is an integer. But it should print this is not int if the variable value is not int. Now, and the most important missing piece of this I give away as int to test the condition. If a value is an integer, you can use the condition is the type of value actually an integer. If this is true, it should print this. If this is not true, it should print that. So, ga ik dus nou? Write a piece of code based on if and else that does exactly this. Okay. here you have to close the string also.
Okay.
So what your goal is, you would like, so if there is some value, let's say 3, you want to test if this is this an int or not. So this one, there should be some test, does value equal int or not? Because if it's an int, then it should print this value as integer, otherwise. Yes, so some of you got there, some of you are still struggling, and we'll let them as well, like, actually you learn most from struggling. The goal is, let's say there's some value, and then we want to test is this int or not. So if it's 3, it should print this is int. If this is 3.5, it should print this is not int. If this is hello, this should print this is not int. Yeah? So the condition is int now with header. What you can always do is just copy some working if else thing and then just think about what is the condition and what needs to be printed. Sorry, I'm in training. I'm in training. I'll show it for you during this time. Okay. And then what should be printed is, of course, if that condition is true, this is int. And if it's not true, it should print this is not int. Now the big question is, of course, what is the condition? Funegger had already the right condition, and actually I wrote it also on the board, but what I remember from, sorry. Yes, but that's because your test is not int, test is true. So the test needs to be, is this int? Now in the back there is already the right answer, but let me first give one that seems right. What do you think? Elekena? Let's try. Okay. Okay. It always prints this is not int. That's not correct, of course. This is an int, so it should print this. Can you think of a reason why is this false? because apparently it's false, because it ends up at the else. Kun zoals integer. Als je chicken bent.
I think it's not referring to the type. Should write type.
I should write type. Yeah, actually I already wrote the condition here. The condition to test internal measurement is we should test the type of value so we should ask to Python what's actually the type of value. And then we should ask to Python, does that equal int? Now, if that's the case, then it's int, else not. Now, from previous trainings, I saw many people doing the test int equals 3. Now, int equals, of course, int. 4 equals 4, 3 equals 3. But 4 does not equal int. 4 is an integer, but not all integers are 4. Int can be 4 or 3 or 5 or 11 or 12. All monkeys are animals, but not all animals are monkeys. So that is why this test does not work. Only int equals int. In other words, only the type of 4 equals int. And so that's why we need to specifically ask for the type of that value. So that's how we build up our condition. Value is 3. If the type of this value is int, then print it, and else print this. Good. We can go one step deeper even. We now have if and else, but we can include in between else if, and in Python that's written as elif. And that is kind of Bihonus je do that. Bihonus kalone do that. Bihonus kalone do that. Kalone do that. So in that way you can start to include as many different actions as you want. If it's lower than 100, do this. If it's lower than 200, do that. If it's specifically 350, exclude it. If it's that, visit, kalone do that. So then really you can start to make nice programs. So with the elif statement, we can include as many different actions related to different conditions as we want. Now, do the following. Copy the earlier code, the one of between 0 and 10. Ctrl C. Copy it to below. And the one of, is it bigger and smaller than 10? Then change this one into elif. And we're going to add a Lela if before. If type value is not int and type value is float, print so copy this, change this if into elif, and add above that the following if. If the type of value is not int and the type of value is not float. Print. And if you did this, run your code with 11 sols, but also with a string, for example, with value equals hello. Okay, so most of you already got it. So if you did this, you can try it. This is normal behavior, out of range. 3 should be, you chose 3. But now if you enter a string, it prints not numeric. And that's very good, because if we only would have this code, okay. Yeah, that's okay. And you only think capital 3, so yeah, that was because I was still 5. So, yeah, but Python does not know what the other is happening. So let's say your first language value Python. So if you then run on this, then it works with our value is 5. Yeah, so if you run only this, then you choose 5. And because here the type print, you choose the string. At this moment, value is 5. But now we're with it. It only runs what you select. So that is, it doesn't check anything. If you select this, it does not check this. But secondly, it of course remembers what you put in memory. So if receiver repeat, you run something here that changes value. And then voila, you use value here, it will use a value. Not the a value, the a value. You can use this line for okay, so it's
and then it prints UTF-11 because value reported. So
it only runs what you select here. But of course, if something is already in memory, it will take time. Yes, sir?
Yeah.
Name hello is not defined. Yes, only here you should use value, I think,
Yeah.
because now it simply takes the old value. The old value is Azrand. Nine. No, that's 9. Okay, not 9. Yeah, you choose 5. Now, if you change value into hello, and you probably simply did hello, then it's some variable name, and Python doesn't know that one. But we are interested in the string hello. Nine. Oh, shit. Yeah. Yeah. Good. Okay, now I think everyone has it on a laptop, and now I want to point out something important. If we set value to hello, and we would only have this piece of code, if value bigger than 0 and smaller than 10, then we would run into an error. At this moment, value for me is hello, so if I try to run this code, it says this one is not supported between instances of string and integer. In other words, if value is some string, you cannot say, is that bigger or smaller than 0 or something? You can only say bigger or smaller than between quotations. So that's why our final code is much better. Because our first test is it actually numeric? If it's not numeric, then we are going to protect our code, and then we are just going to say not numeric. Only if it's numeric, it's allowed to continue. And we can see that from the logic of the code that will appear on the screen. Yes? Here I'm of course testing. Is it actually numeric? If it's not an integer, and it's also not a float, it's not numeric. So if this is true and this is true, I don't want it ending up here. So then I just print it. In other words, if and if else statements are very nice to filter your data, but also to prevent errors. Because, well, here errors are not a big problem, but if you finally start to run your script, put it on some virtual machine with it, you don't want errors. Because errors means the program shuts down, it stops everything. So always think, min situations, manawat yona. And are those situations a problem? If those situations are a problem, well, put some if a situation other, print or do this or that, instead of letting your code run it. So a very important part of if and if else is to prevent errors from happening. So with if, elif, else combinations, we can sort out input, avoid errors, perform different actions with it, as long as you can make the right conditions possible. So, just to summarize the if, elif, and else statements, all code in an if loop will be executed, bonus true. If the condition equals false, the condition of any following elif will be checked. All code in the first elif will be executed, bonus lipping. And then elif or else blocks after that will not be used. Only if all if and elif statements are false, only then the else block will be executed. The final part about if statements, and then we'll run into some small examples and a game, is nesting if statements. That's the final topic related to conditions. You can also nest them inside each other. So you can also add if statements inside if statements. You just need to make sure that the indentation is right. Yeah? From this moment in the training, we enter already a bit in the code that takes you a lot of typing work. So I simply did the typing for you. Especially for module 3 and 4, a lot of code is provided by me. That's also the case now. Just open the following .py file from your folder code and to example code.py and we'll check section 1 if logic. So from your folder code, open m2 example. And then we're studying this first section if logic. And that shows you nested if statements. Consider the following code. It's similar to what we already saw. Now, it first checks whether it's true. If it's not an integer and not a float, well, if it's an integer, then of course this is false and true, false and true minus false. So this all will be skipped and will just end up here between 0 and 10. If it's a float, we'll end up, this one is false because it's bigger than 10. We'll end up here. So with the current code value is 11.5, I'll end up at sustain. This value. If I simply add the number 3, it prints you chose value 3. That's the code we already saw this morning. You typed it yourself. However, if it is not an integer and not a float, it's not numeric, a bit more will be happening. Let's say we use the value hello. Now let's follow the logic. If it's not an int, true, and not a float, true. Okay, we are allowed to enter it. Print, you did not pick a numeric value. Okay? But after that the code continues. If the type of value is a string, in this case true, okay, we are allowed to enter here. Print, why did you use a string? In other words, we can put an if statement inside an if statement. Only if this is true, the code will reach this one, and then if this is true, the code will reach here. If this is false, then it will not never even check this. It will directly skip all of this and move to. So we can put them inside each other. So with hello, it prints you did not pick a numeric value. Yeah. And then it evaluates this one is true, and then it ends up here. Why did you use a string? If instead we use the value true, mijn eigen variable true now. Bouwen voor cement. True and false were booleans. So if it's not an int, true, and not a float, true, print you did not pick a numeric value. If it's a string, no, it's false, skip. If it's a bool, yes, okay, print why did you use a boolean. And so that one will end up in there, F9. Or if this would, for example, be a list, 1 and 2, then it would be not an int, not a float. Okay, you did not pick numeric value. It's also not a string skip. It's also not a Boolean skip. Else, so it would end up in this else. Print, why did you use a value with the type? And then I'm just cheating with, I'm just letting Python check what is the type of this. And so if I run this again with value being a list, then why did you use a value with the type class list? And so you can put if statements inside if statements. Yes. As we can see, we have nested if statements inside if statements. So these are all at level 1. If this is true, this will happen. If this is false, it will move to here, to here. But inside there we have a level 2. If this is true, then it moves into here. If this is true, if this will happen, otherwise this will happen, otherwise this will happen. So you can put them inside each other, you just need to make sure that the tabs is right. This is part of this one and the tab. Then we have this one. This is part of this one and the full at the tab. Yeah. So yeah, it's just keep track of your tabs. Okay, before we move into a game naar Bonaire, you can decide, do you want to be Ashanati or do you want to Bonaire? I just have some simple questions to check, are you able to follow the if, elif, else logic? Yeah? So check the code on the screen and tell me what will the value of out be. So consider this code, value is 3. Will out be 1, 2 or 3? Should be easy.
1.
1, of course. First 3, if value equals 3, true. In other words, we end up here. Out is okay, perfect. What about this code? What will the value of out be?
3. No. 2.
2, of course, yeah. This one is false, okay. This one is true, yes, this one. What about this code?
One.
Not 2? One or 3? Seven, 3, 2. It will be 1 because value is 5. If value is bigger than 3, true. So out is 1. And then it stops. No need for a Kalahona if the Bihonus is okay. So even if later on something else is also true, that later on will never be reached. It will simply stop by the first true it encounters. If this one is already true, then out will be 1 and the rest of the code will be ignored. What about this one? I messed a bit up with the house, but it still works. 7. Yeah, exactly. Because value is not 3. Value is also not 5. It's not the integer 5. No, it's just false, false, valid. Yeah. What about this one?
Two.
Not 5. I heard one answer. Is everyone agreeing with 2? Or 2? Also 2? You also have 2? Now, again, sorry I let you wait, because the correct answer was indeed 2. Because 5 is bigger than 3, true, so we enter this. Even if all of this would be false, we would never end up here. This if is true, so we never end up at the corresponding elif. So, if something will happen, it will happen inside this if. Now, okay, then we're going to check. If it's bigger than 5, no. If it's 5, yes. Okay, stop. The first true encountered will be used. Stop. And it will only stick to what? The true it has. So, if this one is true, you can never anymore end up here. Even if this will be false and this will be false. And there will be no edge. No. Okay, the final one. I think.
What is the answer?
The question is, what will the value of out be? Oh, the alpha feet, hoe laat het met But this is negative. Now, yeah. I think, I hope all of you, but at least Messenger sees the logic in it. If value is 3, no, it's not 3. Okay, skip all of this. It can be very nice code, but it will never be reached by 5. It will directly skip. Elif is 5, no. Then else. Okay, and so it will end up at the else. Good, and that was the build up to the if game. I made a game for you. In Spyder, open the following script m2 if game.py. I lost my. Only open it, change nothing. m2 if game.py. Open this. And change nothing in the file, but only this once you're allowed to use the big green button. So just click on this, run this full script. Just run it. So open m2 if game.py and run the full script. And then it should say run file if game. Huh? Run number. In this file, there is a function, you can see the function def, function ifGame, with 3 arguments. Yeah? Last week we saw functions. There's also a function and it takes 3 arguments, and it also has some default values. But the 3 arguments are version, which version of the game are you playing? Input, what do you want to put into the game? And broadcast, where do you think your input will arrive? Now the goal of the game is the following. Yeah? I hope it's well, of course, but more specifically, why do I let you play games instead of continuing with the training? I want to test whether you can follow the logic of if, elif, and else. In this one, bezoek conditions are. Yeah? And you can win this game if you can follow the logic of if, elif, else. If this is false, then I end up here, then I end up here. Just the logic we saw earlier, but now a bit more complicated. That's the first goal. The second goal of this game is to show you Leeuwenhoek conditions, to show you a variety of conditions. Yeah? So here, in this script, you will see Leeuwenhoek conditions, and it will give you ideas for if you work on your own code, if you need a certain condition. Well, that is inspiration for this game. Now let me first explain how the game works, and then let me explain how you can become the winner. The if game. Let's start with version 0. There are 3 versions to this game, version 0, version 1, version 2. Version 0, there is only one simple rule. Only use integers as input, otherwise you will get an error. Now, if you want to play version 0, then you do the following. In the script, you make sure that version 0 is visible. So you scroll a bit down, and you check version 0. You don't have to run it, you just have to check it. And the question is, if you put something in, where do you think you will arrive? Will you arrive at block 0, block 1, or block 2? Let's, for example, take the first one. If input equals 0, we end up here. What does input need to be to end up here? Bemin input kaart. Let's see, and when is this true?
0.
Exactly. Input needs to be 0. Yes. So with input 0, we think we'll end up at block 0. Now we can test this. This I'm sure is right, but we can always test our guess by playing the if game. How do you play the if game in the console? So you can say if game, and then indeed if you open it, you see it's a function, and the first argument is a version, second argument is input, third argument is block s. Now we are playing version 0. Our input is 0. And if we put 0 into the game, we guess that we end up at block 0. Right? Bihonus input 0 now will end up at block 0. So input 0 will end up at block 0. And then the game will tell you whether you are right or not. Now in this case we guessed correct because it was rather easy. Input 0 indeed ends up at block 0. Now, if instead we would like to end up in block 1, the min input card, do we end up in block 1? If you check the code, how do we end up here? The min input card, that's the question.
Any value greater than
Exactly, any value greater than 0. Version 0 of this game is very easy. So, for example, 5. Yeah? Now, we can test our guess. You can do arrow up in the console. We're still playing version 0. But now our input is 5, and we guess that it ends up at block 1. Now, again, this is correct. So in this way, you can check the code and then think, the input card, I will end up at block 1, at block 2. You can check your guess, by checking here. Version 0 is very easy, of course. Version 1 becomes a bit more complicated. Version 2 is quite a pattern. So let me quickly introduce you also version 1. For version 1 also use only integers as input, otherwise you will get an error. So if you think that input 4 will end up at block 0 for version 1, if you're playing version 1, scroll down of course. Check the code and check the min input card. Do I arrive somewhere? If you think for version 1, input 4 will end up at block 0, if that is what you think, well then you can test it. In this case, your guess was incorrect. Input 4 does not end up at block 0. So you need to find an outcome. Now, version 2, there really LeoNet conditions are. All types of inputs are possible. You're allowed to use integers, floats, strings, booleans, lists, whatever it is. So if you think that input hello will end up at block 0, you play of course version 2, you write as input hello, and you think it will end up at block 0. If instead you think it will end up at Leyland block, well, then you should guess Leyland. Now that leads me to what kind of assignment or game for which there can be one winner. And we take for this game, including the Bunaerut, Abadek. And because really this is, you don't learn Python from simply learning the tools, but you learn it from practicing. Through this game you're forced to practice. And the goal, how can you become the winner of this game? You are the winner if you are the first that finds all answers. And so find input that for version 0 leads you to block 0. But that one we already found, that was 0. But also for block 1, we also found anything bigger than 0. But how to end up here? And for version 1, how to end up here, and here, and here, and here. And for version 2, how to end up in these different blocks. How do you play this game? If you play version 1, make sure you see version 1 and then follow the if logic per min input card. Let's see. Yeah. And if you want to play version 2, make sure you have version 2 on the screen and then check the min input card. Do I end up here? And in that way, try to find the answers for all of them. And you can always check your answers by trying them out here. If you think that something arrives, version, input, bedet, in block. Is this good? So then let's say we take up to Arad Kahai, including Buna.
Okay.
So that is kind of strategy. You can try to be the winner.
is working. I think this is a light. Huh? No. Mabrat il. Kalay mi barom. Mi barom.
Make it quicker. See, did you find any nanometer version and? Yes. Lente? The version 0 nanometer. Lente? 0 nanometer. Let's put it. Good. So this is. So Leonid options. Yeah, so for version 0 nanometer. Yeah, good. And Lente?
Version 0 not.
Yeah, right. Version 0 nanometer were the most doable ones. Then version who let, I will only point out things finish and you can check it out later on yourself. But if we quickly check version 0 nanometer, then of course we watch version 0, that one we already found. If it's 0, then it will simply annotate. Can't to be honest, if it's bigger than 0, any number bigger than 0 will annotate. Can't hold but any number smaller than 0. So the third one we'll find if game with first we're playing version 0, if it's the input is negative 100, then it ends up at block 2. Yeah? Anything smaller than 0 is not 0 and it's not bigger than 0. So block version 0 color. Version 1 also still below, so that was a good now. If you play version 1, how do you end up at block 0?
Block 0. 1. Input is 1. I mean 11.
11. Let's say 11. Anything bigger than 10 and smaller than 25. So let's say 11. You can do arrow up to find all commands. And then if you play version 1, and indeed with 11. Yeah, correct. How about the second?
30.
Yeah, so anything bigger than 25. How about this one? Just
Six.
6.
Give me
Two.
correct.
2.
Yeah. 2 or 3.
3 not, I think. No. Because 3 is not smaller than 3 and also not bigger than 10. So it needs to be anything smaller than 3, minus 2, 1, minus 5, or bigger than 10. However, 11. But what happens with 11?
It's end up with
11 already ends up here.
yeah.
So can you think of any number that is bigger than 10 that ends up here?
1 even.
Not bigger than 10. Kaasebeleid. Azraant will not work because Azraant ends up here. Hamza will not work because it will end up here.
15.
Azramis will not work because it will end up here. Kaasebeleid. Kahayamis. There is only one number higher than 10 that will end up here. That's the number Hayamis. Hayamis is not smaller than Hayamis. It's not bigger than Hayamis, but it ends up here and then it's indeed bigger. And so, Betja Ka'aser Balai, Betja Hayamis will end up at 2. All the others end up somewhere else. This one will of course end up in block 1. And below Hayamis will of course end up in block 0. But anyway, that's just the approaches. Kalhonen. Amis, that's it. Yeah. Anything that is not bigger than 10, not bigger than 25, not smaller than 3, maar let Utersos will end up here, or 4, or 5, or 6, or 7. Yeah. So the sauce that we tried earlier is actually ending up in block 3. Okay. That is just Kutrus. Version 2, I'll not show them all, but I must point out, especially from here you can find Leonid interesting conditions. Version 2 filter, especially if something is a string. If it's a string, it enters all of this. But it also shows you that, for example, this one is very easy. Because if it's not a string, then we just pass all of this and we directly end up here. Bemindelijke variële nummer. If type input is bool, bool. What is a boolean? Very start of module 1 we had
If it is true,
exactly.
Boolean.
But the thing is, sorry, are you going to type the version first? If game, come on, the version number, and the string in the middle of the.
Yeah, that's just possible. Because if you check the if game, then it will say majority argument is version, it doesn't equal to the bulletin argument is input. If you want hello as input, you should type hello as string. So if you're playing version 2 and we were interested in the boolean, for example true, and our guess would be it is ending up in block 4. No, that's true. Input hello does not end up. Yeah, so in that way you can just play it, will not do it here. But anyway, from that, remember, yeah, well, if this is a string, then then is gebouwd. You can be on a string element. Then, if it's a bool, we end up here. If it's a float, what is a float? Can you give an example of a float? Decimal, 2.5, 5.6. That will end up in 2.5. If it's a list, then well, then we do 2 more checks. Well, if it's a string, I will only still explain this one because this is a nice condition. If it's a string, then there is some test with one of those string built-in functions. I hope you remember. We tested with it with long string. Long string, don't capitalize, don't test. But there are also some tests in there. You can also test something about the string. For example, if we have this, just watch my screen. I'm going to do the string 5. Then I can do is numeric. That's just one of the, if I do tab, I get all the options like capitalized, but there is also is numeric. Open close. And that is just testing, or better even, it would be, I'm using a decimal. Dat is testing. Kun je heestring, hoe noemen we decimal numbers? And in this case, it's not meant, does it have a decimal point? Decimal, maar is it the decimal system? Deca is, stands for Latin, is Latin for 10, maar is it 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9? Goed er nou. Hoe noemt goed er het jou? Wees goed rijden. This is true. If this is true, we know, okay, it's safe to turn it into an int. So then I can do int test. And then I have integer. If test, however, would be low, then test is decimal. We'll give false. So this is a very nice one to build in to your function if you import data from Excel, and they are all strings. You want to turn them into Goodrich. First test, are the strings proved Goodrich? Or is there maybe some text in it? If there is text in it, you need to do some additional processing before you start. Well, that is what is happening here. If it's a string, then if this string Goodrich now, then turn it into an integer, percentage sign 2. Do you remember what the percentage sign did? Met dat percentage sign Sabat. What's telling us? The remainder, exactly. Then we do percentage sign roulette. In other words, we check is it an even or an odd number? Because we test if the number percentage sign roulette equals 0, any even number for percentage sign 2 will always have a remainder of 0. This will also have a remainder of 0. Any odd number, of course, is a remainder of 1. So this is a nice test if for some reason you only want even numbers. If, well, the number percentage sign 2, if the remainder is 0, maar then it's even. Well, then you can 0, if it's an odd number, it's 1. Well, the rest you can check at home. Today we have no winner because of that. Anyway, this is for you to follow the if check. And just before we will move into loops, I want to give one advice. Advice for creating code, a logic tree. If you have some goal, with a collection of tasks related to if statements, it might help to first make a logic tree. Now, I'm not sure whether this is the official name for it, I just thought I would call it a logic tree. Because also with programming, you can have one goal. For example, make a graph of specifically the all data belonging to Agaminch. And then you should not see it as, oh, one big goal, but then I know how to make a graph. No, you should split it up in as many different steps as possible. And along these steps, you might want to use logic and conditions. If the number is that, I don't want it. If the number is that, I want it on this. So you can on paper draw a kind of tree. If I go here, then there, then there, and there. That is actually the hardest work of programming, to make a logic order, logic tree of your code. That's the hardest part, but you can simply do it on paper, and we'll just quickly do it together. So if you have to make one goal, just divide the road to the goal in single steps, put them all into a logical order, draw the different branches of the tree, and then After you've done that, put the steps into code and you test, of course, the individual steps. Because all code is simply a collection of inputs, for example, into some function, conditions, and conditional code, connected by branches. The branches of true, then move here. If false, then move there. After that, move there. So all of this, all your code, you can logically write on paper. And as soon as you've done that, it's very easy to turn it into code. One example. A forest fire warning function. Let's say that SNMPR comes to you and they want you as an engineer to design a forest fire warning function for Nesha. And they say, we have a temperature sensor and we know how to connect it to the computer. But please, for us, can you design a function that creates a forest fire? Then you should not do, okay, on Google, how does a forest fire warning function work? No, you should simply see it as one goal and divide it up into logical steps. So, for example, a function for a forest fire warning, getting temperature values as input, with the following requirements. Yeah, those you can just on a piece of paper, you can think for a forest fire warning, min. Now, then, so that if you get a negative number, then you know, in Arbaminch, negative temperature is it will always be 0. So, simply, if I get a negative number, you can print a message, check your sensor. If it's from 0 up to and including AMSA, that is still possible. So then you can print a message. Temperature is temperature is high. If it's Kahaya antes Kasostometo, well, then it's getting a bit hot. So then you could print temperature is high, check circumstances. If it's Kasostometo for light, Kasostometo, and then the nigger can already start working. Yeah, so Kasostometo for light you can put just in your program temperature higher than Sostometo. Watch out for fire. Yeah? Maybe you don't agree with this, well, you can simply change it, of course. It's your forest fire. Or water quality warning. If you have a water quality sensor that gives you more, then you can think of min and which utmost and then put it into logical. So let's just quickly do this together because it is not easy. And let's move step by step. The first thing is to break it up into single steps. And the second thing, which you can do at the same time, is to put it into logical order. So, a function for forest fire warning getting temperature values. So you know, okay, as input I'm getting temperature values, and I need some function, forest fire. The requirement, a negative value, print a message, check your sensor. Okay, so I need apparently some condition, and I need some print statement. Other values, so I need another condition and another print statement. And I need another condition and another print statement, and the final condition and some print statement. So these are all the different parts to our forest fire warning. Now the only goal, or the only challenge is to put it into a logical order. And after we've done that, it's very easy to put it into code. So let's just quickly do that together. Space to write. So this part, the hardest part of programming, you can simply do on paper. Put your stuff into a logical form. So let's do that now together. Going. What do we start with? What's at the start of our code? What's at the very of all these parts? Mendiger met Jamrian. So the goal is to put all these different parts into a logical order, to draw kind of a tree with branches. What do we start with? The value, the input. and it will be the temperature. Where does the input go into?
Into function.
It goes into the function. Yeah. So we have some function that the forest. And this function will have one argument, the temperature, of course. Okay, that's the function. As soon as it's in the function, what does it encounter? Sorry? Now the value comes into the function. Then
Soon after condition will be defined.
a condition, exactly. We need a condition. Yeah, we have a value, goes into a function, but we need to filter out. So we the condition. Condition. Which is which condition?
Less than 0.
Okay, so that will be less than 0. If false. No, sorry, if true. If true, what will happen? Some print statement. Print checks. If false, what needs to happen? So if this condition is true, we will print please check. So if this condition is false, what needs to happen? Yeah, no, that is if it's true. So if smaller than 0, we need to check that because smaller than 0. So print check. If true, print. If false.
That's still another condition.
Another condition. Yes. Condition 2. Which is bigger than 0, bigger or equal than 0, and smaller than or equal than outside. Yeah? If that's true, what happens? Just print the value. Just normal. If that's false,
Next condition.
sustain condition. Which is smaller than sustain. If that's true,
That's high.
yeah, print some other. If it's false,
Last condition.
last condition. Because it's the last condition, we can also say directly print. If it's true, print this. If it's false, print something else. Right? It's kind of the final condition, but it's color. The others are, this one is be honest, color be honest, color be honest, color. So then it's print watch. This, what we just tried to do, and also distinguishing the two. That is the main challenge to code. As soon as you've done this, putting it into code is very easy, and it's just depending on your type. Just to show you that this works, I will quickly type it, but it's not necessary that you copy the code. Yeah? If you want to copy something, you should copy this, because this is where all the thinking happens. This to code is just, yeah, do you know how to type? And do you remember what the correct function format and if format? It's not, those are just tools. The hard work is this. So, if you have this on paper, and the more complex your task is, the more rewarding it is to first draw it out in paper, And when it's just perfect on paper, well, yeah, I can just copy it into code. Because now I can just follow all the branches. There is some input value. The value doesn't really matter. Value, let's say, is 15. But more importantly, I should start with a function. Type here.
Yeah.
Okay, let's yeah. Okay, so the first type of my logic tree is the function. So I can just make a function first. Warning. And that one takes only one argument, temperature. Okay. Then it should run into a condition, so I should start with if. And the first condition is if temperature smaller than 0, print check sensor. Okay. If that's false, there should be a second condition. And if temperature smaller than Hamza, smaller or equal than Hamza. Here I said bigger or equal than 0 and smaller or equal than Hamza. This one is not absolutely necessary because if it's smaller than 0, it's already captured in the first. If it's smaller than 0, it's captured here. If it's higher than 0, gun smaller than Hamza, then we want to just print. So, and if temperature is smaller than Hamza, print the temperature is plus string temperature. Combine two strings, turn the value into a string. Okay, if that one is false, so stay in condition. And if small temperature smaller than 300, print the temperature is high. Check circumstances. Else print watch out for fire. So now I just put our logic tree into code, and I hope you realize that all these different parts are very easy. You just have to know the realize function definition, function name, argument name, colon, and the rest. You simply have to know how to do if some condition, colon, some action. And if some condition, colon, some other action, or some action. And so the tools are very easy. Now let's try out this function. First, warning. If it's minus, if it's negative, check sensor. If it's 5, normal average temperature, yeah, correct. If it's Hamza ant, temperature is high. If it's sustained ant, watch out. Yeah. So just like that, we created well. Which one do you want to see? Or do you want to see the code? Ah, okay. Okay, let me. No, I'm not. I'm not going to put this away. I will show you the code once more, like this. But the code is not relevant. Right? This is where we did the thinking. The code simply shows you the tools. And this is a forest fire warning function. You can make a water quality warning function. You can make any function. As long as you know the logic, you just combine the tools. Good. Apologies, I'm going to click this function. Because I know I've discovered in these trainings, most of the trainees are addicted to copying code. You learn nothing from having exactly this code. The lesson here is combine the logic. And the lesson here is, of course, how do you make a function, but it's already about the function. How do you make an if statement? Well, that is this more. This function itself is totally not relevant to have in your code. It's much more relevant that you understand the logic behind it. Good. I'm going to wipe out the logic. Click away. Okay, it's gone. Okay. Yes, and before I want to move into loops, I want to introduce an assignment that is that you can find in the PDFs. And that assignment has to do with the function you made Badefossement. Badefossement, you made the group division function. But with the group division function, there are two problems. The first problem is, if it's not an integer or a float that someone puts in, let me quickly show you. Oh. This, yeah, here we have it. Yeah, this was our function. Group division, F9. I function of gun. Like this it works. It doesn't work if someone would enter a string. Yeah, because with a string you cannot calculate. And now you can become angry on this someone that uses your function wrong, but in programming, actually, I think beyond 100% of programming is avoiding errors. That is what the guys of Microsoft Excel and Office do. They do not only write Arif program, but they know our programs are used by everyone. And some of those people are very, very stupid. So they might click at places they actually should not click. So we need to make sure that anything that happens, that it does not result in an error, but that always is a nice warning message. So that is what you also can do with this thing. If you make a function, do not only think about the mathematics, but also about error. Maybe someone enters a string. If someone enters a string, now an error comes. But based on what you learned this morning, you can change this function to first test, is it actually an integer or float? If it's not an integer and not a float, do not do the calculation and give a nice warning. Print, please pick a numeric value. Instead of letting the user run into an error, you can program here warning messages to help the user. And that is what assignment 2 is about. Change the function so that if for AOSM or SPG not an integer or float is given, a message is printed instead of an error. Secondly, what you can also do is, if someone accidentally messes it up, step 24. Now we get a result, and that's simply because they were reversed. But you can also program here the test if AOS is smaller than SPG. You can print, did you maybe mix them up? Or you can even force them to change. With conditions, you can do anything. So also, if AOS is smaller than SPG, a message is printed. Did you maybe mix them? Instead of that, simply the answer is given. Now, how can you do this? With if and if else and with the above mentioned conditions and steps, of course, if necessary, make a logic tree complex. If this happens, what should happen if true? What should happen if false? And after that, what should happen? Now, implement this logic tree in your code. This assignment is just voluntary and in your own time, but this is one of the assignments on which you can test and practice with conditions. Good. And that concludes conditions for me. Conditions, the tools itself are very easy. It's just if and if else. But by combining these, you are really starting to program. And you can start doing it. Any questions about conditions? If not, I want to move into loops. Before I do that, you don't mind. Now the remainder of this day, up to the final 10 or 15 minutes, we'll be dealing with loops. Loops is still part of the absolute basic grammar and fidelity of Python. Python yellow loops, then still it's better to use it. And next how you can use conditions. But Python, the loops got and conditions and functions in those tools, then really you can start to do and conjure later. So loops beginnen met aan als and I already saw it happening with conditions. The tools itself are clever, but by combining all these logical tools, it can get complicated. Yeah? That's not because your Python tools as you got now. That's simply because at some point the logic becomes a challenge. And that's even more the case with loops. Yeah? In previous training sessions, I discovered that with loops, I can get everyone confused. So, also this afternoon is very important that you keep sharp, that maybe at some point we take a small Puna, because with loops it's getting complicated. Before lunch it's getting complicated. After lunch. Loop statements in Python. A loop statement lets some code run multiple times. Code enters here, it enters some condition. If that condition is true, it goes to here and some conditional code is executed. And it's back here. And it keeps on doing this until it's false. That's very nice because you might have some function and you might have 20 years of data. And this function you don't only want to do for Julia, you can, but also for bullet, and you can store resource, and you can. So instead of programming Bazooki say the same function, you can just write one time the function and let your days move through it. So do it for them, do the same for it. Data values, but do just keep on doing the same calculation. Yeah. So you only need to write the code once. Python will make sure it happens as you just depending on how often you want it. Now there are two loop types, and the first one we'll start with before lunch, and for loop we'll deal with especially after lunch. While loop, I think you know while is while something is true. And the for loop. We'll see that one later. But we'll start with the while loop. The idea of the while loop is while some condition is true, just as long as it stays true, it keeps repeating the code within that loop. It only stops as soon as the condition is not true. So, for example, to do something 10 times, move back to your just your own coding book and to code by way. And then below there we are going to write some simple code. We're going to set E as 0. E is 0. E is 0. And then while E is smaller than 10, print E plus this. So write this code. type this code into the script editor, then run it and tell me what happens. What does it do?
Yeah.
0. Yeah,
Yeah.
it prints 0. Check. Done. 0 up to 9. Yeah. Yeah. It indeed prints 0 up to 9, and that's exactly what we ask it to do. Because we ask from Python, we set E at 0. And then we say, while E smaller than 10, print E. And then turn E into 1 higher. Remember this? This is the signing plus mathematical. So E is 0, it prints 0, and then E becomes 1. Still smaller than 10, prints 1, becomes 2, it prints 2, etc. E is 9, 9 is printed, E becomes 10, E is not smaller than 10, because 10 is not smaller than 10, it stops. And so it continues until this condition is false. Now do the following. Delete the final line and run it again and tell me what happens.
It's not going to stop.
Yes,
It writes 0.
that was on my next slide. I maybe should have warned you.
Hmm?
If you do not program your loop carefully, you can get stuck easily. So with this one, E is smaller than 10. Yeah. E is 0. So it prints 0. E is not changed. E keeps on being 0. So it's always smaller than 10, so it keeps on running. Yeah. The Python can go on and on. The Lenya trigger, because we are actually not interested in continuing. Let's also destroy my. And so it's just going on and on. Now, one solution is just throw back your laptop, throw away your laptop, come up to the new one. Or fully close down your laptop, of course, that would be another solution. Luckily, there's a bit more straightforward solution. There is this red button. And that means stop the current command. So you can hit this red button and then Python stops. This can stop the current command. And then actually you get kind of error. Keyboard. That's kind of Python's way, like saying, well, I was able to just continue and go on. But someone forced me to stop. But that was in this case also what we found.
Yeah, let's try to.
Is it back?
Yeah, it's back.
There's actually one other way to do that. If you get stuck eternally, or if you have some code that accidentally takes a bit too long. Now I'm stuck again. I can hit on the red button, or I can activate the console, click on the console, and use Ctrl-C. Ctrl-C is exactly this. For that you need, of course, to be here. If you are here and you do Ctrl-C, you are copying. But if you are here and you do Ctrl-C, you force the current command to stop. So that's important to know. Yes. So the most important thing is always think about your loop. Make sure to program it. If you happen to forget it, then when you're still on your computer busy, then it doesn't really matter. You can solve it with the red button or Control C. However, if it's some program that you put on some virtual machine or on some piece of software, and accidentally somewhere in your code it can get stuck internally then your instrument freezes. So make sure to program there. In this way we do that by forcing E to increase. E plus is 1. That's much better. Okay, small point. This is exactly the same as functions if and if else concerning the indent. Again, some keyword, in this case while, colon at the end, and everything belonging to this while loop should have a type. That's just how Python works. Keyword def, you're starting to make a function, but end with a colon, anything belonging to the function. Keyword while, you're going to make a while loop. End with a colon, and go that tab. So tabs betaan async. Good. Let's just start using some data. Next week, no, not next week, I do not know yet when Module 3 comes, but in Module 3, we'll study in more detail how to import data, but already today we are simply going to use some data. In the folder data, under your project, there should be the file n2grades.csv. And I want to quickly show you min-inet data. You don't have to open it, I will just show it to you. Under data, there is n2grades.csv. And this data we are going to use today to calculate it based on some loops. What is in this data? In there are 4 columns of data, and this is data about students. So we have a student number, and is Mutterselassessement. So Mutterselassessement te maken. All of these students were in a certain group. For example, student 1 was in group 2, student 2 was in group 5. And student 3 and 2 were in the same group. Now, all students got a certain score for a project. This project was group work. So you can see that indeed students 2 and 3 got the same score here because they were in the same group. Yeah? The score out of methods. All the students also sat in a final exam, so they also got out of 100% some score out of 1. This student scored 0.6. Yeah, so we have grades for Mutterselasse te maken, another grades the group work, another grades the final exam. Now these grades we are going to load into Python, and we are going to do some loops on them. So do the following: open n2grades.python. Do not yet open it, only open it. n2grades.python. Then secondly, do the following. Check this and make sure it's set to, the final one should be basic Python project. I think for most of you it will say /code.
Yeah.
It should go one up. And it should go to the parent folder of code. In my case it's software training, in Janette's case it should be basic Python. Yeah. So if this is /code, click on the arrow up to move one up. So set this directory to basic Python project. That's your project. If you've done that, open the script and run the section load load data. So select the section load data and write. So select all of this and it should run without error. If you get an error, restart. Error yellow?
No, error.
Hoe doen ze dat?
Yang nggak pada setengah. ጋፕ ኢፌክት የለውም እኮ እንዲታይ ነው እንጂ ይሄ ኢምፖርት የሚደረጉት እንትኖች ናቸው። ፓንዳ ኢምፖርት ፓንዳስ የሚለው ሞጁሎቹ ነው ኢምፖርት እያደረገ ያለው እንጂ ሌላም አንድ ነው የሚለው ለቪዚቢሊቲ ካልሆነ
Yes. Yeah. Okay. Very good. Now, what did we just do? We imported the data into Python. And that happens here. We'll study this in module 3 in more detail. But I'm loading the m2 grades.csv, which is in the folder data, which is in the folder basic Python project. So that is why I go to the basic Python project. SK basic Python project, it will continue with data m2 grades.csv. That one is in load. It saves it into grades. And then I pick a couple of things out. I'm going to say project grades, which is the column score project, times underneath. Yeah? We saw 0.6, that will now become 6. So I'm changing it to percent. And I'm storing it into a list. I do that because we already know this. In module 1 we already saw this. So project grade will be a list of all grades scored on the project. Likewise, exam grades will be a list of all final exam grades. And besides that, I'm also creating a list of all group numbers. G0, G05, G05, G0. And that I'm storing in group names all. So those are the things you got from me. And you can check that yourself in your variable explorer. In your variable explorer, there should now be an exam grade list. There should be a group names all list, and there should be a project grade list. And all of them have indeed methods, zoals ze met Coolidge. We can check the first one. Project grades. If we want to check the first one, we can slice into it with numeric footer. That is Semanya count. Let's quickly check in the original data. That's indeed Semanya count. 0.8 times 100 becomes Semanya. Let's do the same for exam grade. Numeric. Chelsea. Resource. Look now. And group names all. This person was in group 2. Yeah? So data. And the data is inside lists. And that's nice because we already know how to work with lists. We saw it. Module. Est-ce que c'est dus? Ja? Data. Now we created the list project grade, exam grade, and group names. For Mutters, Lasse, Tamari, there are project grades, exam grades, and groups. Now we want to make a new list. We want to make a list, something like what SMX is doing. We want to make a list, final grade list, which for each student is project grade times 0.4, project counted for Arba, plus the exam grade times 0.6. Final exam was counting for 6%. So if we would, for example, want to know the final grade for Montgomery and Tamari, we should calculate it like this. We should calculate project grade 0 times 0.4 plus project grade, exam grade 0 times 0.6. I hope you remember from last week, you don't have to type everything. You can start with Proi, top, okay, it feels good. And then Montgomery, the money. And then exam, top, Montgomery, 0.6. So, the Montgomery and Tamari, the final grade will be Silsa Cement. That's like, see? Or is that still B? Silsa Cement? Je zoekt goed door Silsa Cement.
Yeah. Yeah.
B. What is that phrase? Is that a B or a C?
It's B.
B. Probably the student at the end of the course will come to me.
I think it is B minus.
B minus, yeah, so the student will come to me and I will get the point. But I'm that bit then I also always say no. Anyway, we can calculate it finally. But this is of course a lot of work. Because we don't want it only for Montgomery and Tamari. We also want it for Bulletanya, Sosne, etc. Each time we want the same calculation. We only want to change 0 to 1 to 2. For that, we can use a loop. A loop is perfect for that. So we want to calculate for Tamari 0 and we want a loop. And that is example 1. And the examples are already here because otherwise it would become a typing training. But we'll just first discuss the example and then run the example to see whether it works. So example 1. Do not yet run it. We will first discuss it. A loop to create a new list. Example 1. First thing of the loop is we are going to use E to keep track of the loops. Because it will help us to stop at the right moment. Yemencherisha Tamari. Countercenter.
Cement. I think so. Satyek, no?
Let's try. Or Methosilasa.
No, it's out of reach.
Lemon? Why do I get this error?
We must be right in the Salasa.
Exactly. So that's in Montgomery and Tamari is 0. Yeah. So that's important to know. Because now we know we need to stop our loop. The final calculation should be with Methosilasa spot. It should stop before Methosilasa cement because otherwise we get an error. Okay. So that's the first lesson. Mecharisha Tamari apparently had a minus. Good. Yeah. Can we have it? Good. So the first step is to set E at 0. And we start, besides that, this is all bit preparation before the loop. We start with a Bado list. And in this list, we are going to add each time a number. Each loop, we calculate the number and we add it to the end. Last week, we saw the good method to add something to the end of the list. list.append. Yeah? So we start with the Bado list, and then to the Bado list.append, będziemy jechać. Pisambowala, Andakutra. .append will return it. So in that way we add until we are at Meto/Sabat, Meto/Simultania. So we start with the Bado list, and then we set the loop to run as often as the length of the list project. What is the length of project rate? Meto/Sabat, exactly. So as long as E is smaller than Meto/Sabat, as Meto/Sabat, it's allowed to do this. So this is good. Yeah? Now, this is setting our loop. Let's now take a look into the loop. Within the loop, every iteration we make a calculation of the final rate. Yeah? Just the calculation we did here. This calculation. The only thing is we add it to the list. So we are going to calculate some final rate, which is project rate not 0, but E. Project rate E times 0.4 plus example rate E times 0.6. And then that we store in the length final rate, and then we say the Bado list final rate is .append this final rate. And then of course we need to increase E. So in the first iteration E is 0, so our first calculation is 0, 0. At the end we turn E into 1. It's still allowed to continue, so we do it with the Mari and Poulet. Tot. Zetten we dit zitten. Meto/Sabat, Meto/Sabat, append Meto/Sabat, turn it into Meto/Cement. It's not allowed to continue, it stops. So it does exactly what we want, and the tools itself are not that difficult. It's very easy to type while, it's very easy to create a condition, it's very easy to type a colon, it's very easy to write a tab. Calculation with Ampelalum. Only by starting to combine it, it might become a bit more complicated. But this should do exactly what we want. So now let's run the code of example 1. So select example 1 code and run it. And it's finished under a second. Within under a second, it did Meto/Cement loops. Iterations. So now, and it created a new list, final grade list. So check also this new list. Always when you did something, also check it. Did the code do what I expected it to do? For example, what is the length? You can check the length with length final grade list. So check what it is, and check whether it is what you expected. Okay, that sounds very good. If you're still not fully trusted, you can also, of course, do some random calculations. So, for example, Kutra Hamza. Let's check what this is. Hamza Anlenya Mari. Okay, he did not score very high. If everything is fine, final grade list, Hamza should be the same. Yeah, that's the same. So always try to think of quick checks to see, did I get what I expected? Because you might have made a mistake with the condition, or you might accidentally have started at 1 instead of 0, or you might have stopped too early. So always do quick checks. If this is not what you expect, well, go back to your code and just follow step by step. What does this code do? Skazigas. Yeah, that's it. Okay. So this was just the most basic way of using the while. The power of the loop is, of course, well, to control it with some condition while it's smaller than this. And then, of course, you need to make sure that this this or that also changes. If you forgot the last line, then it keeps on, and then at some point it runs into error, of course, because it's assessment. So make sure you program. That is just the basic one. But we can make it a bit more interesting. We can also control our loop with the keyword break. Now we can control a loop directly with the condition. That's what we do here. We just say let it run as long as this condition is true. So we control it just with the condition. But we can also control a loop with the keyword or the statement break. As soon as code comes across break, it will stop the loop in which it was. And so you can put break somewhere in your code behind some condition. As soon as the code arrives there and there is break, then it stops the loop where it was. So that's another way to control your loop. So for example, go back to the code for the simple one. The E is 0, well, E smaller than E plus is 1. I hope you still have it. And add then the following to it. If E bigger than 5, break. Move back to if if you've done that, run it and tell me.
It's break at 5 before reaching the
Yeah, it stops earlier. So it prints 0 up to and including
5.
5.
Yeah.
Yeah. And the other? Okay. Yeah. Stop. New code, you should just say E plus 1. The E plus 1 is 2. It doesn't change anything. E should change. Run the 0 up to 5. Yeah, it prints 0 up to 5 because indeed we start with E is 0, it's smaller than 10, it can print, it turns into 1. If bigger than 5, no, okay, ignore. E becomes 5, it prints 5, E becomes 6. If E is bigger than 5, yes, break. Okay, the code is allowed to enter break, but it directly stops whatever loop it was busy with. So instead of the condition, we could also just let this run forever, set this to true. But at some point that the code will reach break. Now this condition has no value because this is now the important condition. And that leads me to example 2. So if we move back to M2 grades, there is also an example for using break instead of the condition. So example 2 shows how to use break to control the loop. The goal is exactly the same. We are going to again calculate all the final grades. We are going to create a new list, final grade is 2. Just exactly the same list, but now we are not going to use a condition, but we are going to use break at the right moment. How do we do that? Well, first of all, we simply let the loop run forever. Yeah? While true. This will always be true. So it will loop forever. Chigrilum, because we are going to use break to control. So while true, we are not going to bother about conditioning, it's just always true. How do we let the loop stop? We let the code arrive at break if E equals the length of the project. Methuselah's this, Chigrilum, Methuselah's pad, Chigrilum. So here it calculates for Methuselah's pad. It depends Methuselah's pad. It turns into Methuselah's cement, and on that exact moment we let it. Yeah. Quick question. What would happen if I would do this? Don't do it yourself. So if I move E plus S1 to the bottom. Does anything change? Now in this case, these kind of questions you can answer by following logically what the code does. So E starts at 0. It will calculate for 0, it will append. If it's Methuselah's cement, okay, not yet, it will become mat. It will become Methuselah's cement after a lot of loops. Yeah? Okay, so it will calculate for Methuselah's cement calculation, it will append Methuselah's cement. It will check, is it already Methuselah's cement? No. It will become Methuselah's. It will calculate for Methuselah's. And that's a problem, because we run into an error. So here, we calculate for Methuselah's pad, and then we check, is it already Methuselah's? And after that, we include Methuselah's. Then we calculate for Methuselah's, and only then we would arrive here, but earlier already we run into an error. In other words, the order of your code matters a lot. Yeah? And the idea is not that you directly see this is the wrong order, it should be like this or that. No, sometimes it's really a puzzle. And just like I did now, what you should do, maybe even on the paper, what happens if it's Methuselah's? This is then that. Sometimes you run into an error and it's really unclear why this error occurs. Then you really need to break down your code and follow tightly step by step. In this case, this is just wrong, it should be less. So the most important lesson from this is not what is the right position for this. The most important lesson is the more logic you combine, the more complicated it gets. And that simply requires practice. And the more you practice, the more this logic just enters your system and the more you automatically solve it. But also through practice you run into errors, and that is very helpful because compared to anyway, it matters a lot in what order the code is. Instead of using condition, we use break. So that's one of the tests we do. You run it.
No. Wangitin kun gargacha roko andi gidus kono.
Paper reputably rats publish good. Ma. No. Adalla. hin beeka.
Peepariin sirriitti hojjetamee maqaa isaanii irra jira. Kun maal?
የሆነ ነገር ኮንትሪቢዩት አድርጎ ሊሆን ይችላል። የግድ ዳታ ኮሌክሽን መሳተፍ አለበት እንደ አንድ ግለሰብ? ያው ታሩን ዳታ ኮሌክት ጎዴ ሆጀቴ ኢምቤከ ፔፐሮት ሰኒን በር
ማን ነው ፕሌስ ይወጣል? ፖዚሽን ስላላቸው ነው። እኔን ለምን አላስገባኝም? ራሳው ስለምጠቀም ነው እነሱ ጋር በቃ ጥቅም ነው። ለምን ኔትወርክ አታምንም? በእናትህ
ይሄ እኮ ግልጽ ነው። ዋ ኮንትሪቢዩት ጎዱ ጎሩ ጀቹን እንደሱ
አይ ምንም ሳያረግ
100% አረ
ሶ ዋታ ከንጎን እንገልጭታ
ያው namtichi kana ta'uu danda'a. Namtichi kun waa contribute godhu kiyyarrattu argeera waan ta'eef article irratti. Sun garuu hin godhu. Sun languages ta'u saawwee languages ta'u waa wayii edit godhu malee isatti hin godhu.
ሰብታሩን መልቶ ነው አሁን እሱ ላንጉዌጅ ማስተካከል
አይገናኙም። ታሩን እንግሊዝኛ ያበላሻል። ዋን ቤኩ ሲፈካት ያበላሻል።
ደግሞ መልከን ታይቀው
ለማኑ አድቫይስ ነው ጎደን ይበር
ገባኝ መልከን ታይቀው
አን ወይ ነስረዲን ላል ሳሙኤል ወሊን አርቲክሊ ለመፐብሊሽ ጎደን ከነወሊን አርቲክሊ ለመወጀን የፊልም ፕሮሰስ ይረጀ እንግሊዝ ሊበልስ ማለ አይዲያ ገረ ብራት ዳይቨርት ጎደ ማለ ይሰንጫሉ ani thesis almost proposal lama thesis master's kantu advice da goda kanammo kanatu advice da gocha language in balesa ko taru in balesa kibritin gafadu ani yonso asnaq gafadu warra master's warra phd berchar